Penuh bermisi Guru AYU mencapai misi yang satu, berbisik kita bantu.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Salam sejahtera kepada semua guru, ibu bapa dan juga pelajar-pelajar sekalian. Selamat datang ke Pusat Tuisyen AYU YouTuber dengan usaha sama e-didik Malaysia dan juga Kelab Guru Malaysia. Okey, bermula percuma, selamanya percuma. Okey, cikgu-cikgu perkenalkan diri dulu. Okey, nama saya sebagai Cikgu Kok dari SMK Tinggi Sandawi Melaka. Hari ini saya selaku sebagai moderator. Okey, lepas tu kita akan bersiaran secara langsung daripada channel Mr. P pada petang ni. Siapa yang masih belum subscribe, silalah tekan butang subscribe sebagai tanda sokongan kepada Mr. P. Okey, saya memperkenalkan Mr. P dulu. Okey, Mr. P adalah dari College Tingkatan 6, Tun Fatimah Melaka, selaku sebagai presenter pada hari ini. Okey, turut pada di konting kami ada Cikgu Nur Izian binti Saleh dari SMK Teluk Panglima Garang Selangor selaku control host. Okey, lepas tu kita akan mempelajarkan ulangkaji hari ini iaitu PPT dan juga ataupun PP1 untuk tingkatan 5. Kami akan fokus kepada bab 1 dan juga bab 2 punya paper 2. Okey, kelas ini akan berlangsung lebih kurang 1 jam lah. Okay, sebelum kita nak teruskan kelas ni, cikgu akan ingatkan kepada semua pelajar dan juga penonton yang ingin menghantar komen, sila guna bahasa yang sopan dan juga gambar profil yang bersesuaian untuk tontonan umum. Link e-sijil akan diberikan di hujung siaran. Link e-sijil dapat diisi dengan email e-didik, MO email, email my guru dan juga email Jawi. Cikgu akan berikan kod di sepanjang kelas ni lah untuk belajar supaya boleh tebuskan mata kredit AYU. Link rekod kredit belajar juga akan dibeli tapi di hujung siaran nanti. Okey, silakan fokus kepada isi belajar yang akan disampaikan oleh Mr. P nanti. Okey, semoga kelas kita pada petang ni dapat dimanfaatkan lah sepenuhnya oleh para belajar dan ataupun para guru juga boleh mendapat tips daripada sana macam mana nak keluarkan soalan-soalan pertengahan tahun. Okey, baiklah. Cikgu bagi kod dululah. Kod yang pertama nak bagi ialah A3. A3. Okey, dengan ni cikgu serahkan kelas ni kepada Mr. P. Okey, dipersilakan Mr. P.
Okay, so thank you kepada Pongkok. Okay, so selaku moderator pada hari ini. Okay, so saya Mr. P, okay, dari College Tingkatan 6 Tun Fatimah Melaka. So sekarang adalah musim-musim periksa kan, okay. So kelas yang diadakan oleh AYU ini, so minggu ini kita adakan 2 kelas iaitu tingkatan 4 telah diadakan pada Jumaat dan kita ada buat ulang kaji bersama pelajar tingkatan 4, okay. So berkenaan tentang bab 1 dan bab 2, okay. So fokus pada paper 2 lah. So hari ini kelas tingkatan 5, so kita juga akan buat ulang kaji mengenai tajuk bab 1 dan bab 2. So ini adalah panitia fizik SPM Academic YouTuber. So di sini bersama saya pada petang ini ada Cikgu Kok dan juga Cikgu Izian. Okey, terima kasih bersama saya pada petang ini. Okey, so seperti tadi kita sebutkan, hari ini kita akan buatlah ulang kaji. Okay, we are doing the revision for midterm exam. So I know that most of the students now is actually struggle, okay, preparing their midterm exam. Okay. Okay, so as per mentioned just now, in today's discussion, we'll more focusing in the paper 2. Okay, so this is the format of paper 2, and actually we have many time go through together with you already. Okay, so since we have the Form 4 classes last year also. Okay, so basically we have the 3 section in our paper 2. Section A, which is compulsory to answer, and it actually consists of 8 questions. So the distribution for the marking, for the mark here will be 4 to 9. Okay, and then the criteria will be tested will be knowledge, understanding, and calculation is the actually is a must, right? You can see all of the question is involved in these 3 criteria. Okay, understand, knowledge, and also the calculation. Okay, and the criteria for the conception you will be see at the question number 5 and also number 6. Okay, will be here. Okay, and then for the question number 7 will be we have the modification. Question number 8 we involve in the question regarding the decision making. Okay, decision making, and we have optional question at section B, question number 9 and 10. You can choose one of the question, or you want to answer both of the question also can. The highest mark will be calculated at the end of the marking lah. Okay, so then for the C is a compulsory question, question 11. So this one will be involve the criteria including the conception and modification lah. Okay, and today's we will focus on the question almost same as the format of question number 4, number 5, and number 8 for the section A, and 1 question for section B and C respectively. Okay. Okay, so here focus on today will be I am going to discuss with you all 6 questions, 4 questions in section A, okay, which is from the chapter 1. Chapter 1 we have actually 4 subtopics, 1.1 to 1.4. So I already try to cover all the subtitle as possible lah. Okay, so you can see at the question number 1 and number 2 and section B, okay, all the subtopic, which is the resolution of forces, force of equilibrium, and elasticity will be going to discuss. Okay, and then for the chapter 2, you will see the question at section A, question number 3, number 4, okay, and then also number 6. So for the chapter 2, we have about 6 subtopics. So I think mostly we will cover within these 3 questions. Okay, so let us see our question number 1 at section A. Okay, so diagram 1.1 and 1.2 shows 2 identical mirrors. They are hang up on the wall using the same length of the string. Okay, so you can see the string here will be represented at here, T1 and also T2. So T actually here will be tension lah. So the length for the string for both diagram here will be the same. Okay, and then the 2 mirrors are in equilibrium state. So they will be stationary. Okay, so each mirror has a mass of 4 kg. Okay, and each string can withstand about maximum 25 Newton force. Okay. Okay, so for the question number 1, for A, what is means by equilibrium state? So this is quite straightforward question lah. Okay, so the answer here will be the resultant force added on the object is 0. Okay, so you must mention resultant force is 0. Okay, for equilibrium state lah. Okay, and then for B, okay, so this is a calculation question. So based on the diagram 1.1, this, and 1.2, calculate the tension of the string T1 and T2. So you have to find out what's the value of T1 and T2 here. So the tension is force, so the unit will be Newton lah. Okay, so and just now you can read back the question. Okay, so the question given us the mass for the mirror will be 4 kg. Okay, for 1.1 and also 1.2. Okay, so there will be force adding downward lah. So here we are using the resolution method to solve the question here. Okay, so the component vertical in diagram 1.1, firstly, as mentioned, there will be a weight, okay, adding downward due to the gravity. Okay, and then the tension here are extend to here, left and right. Okay, which is mentioned already at here as T1 lah. Okay, so here is the right angle. So here 90, so here will be 30 lah. So vertically opposite angle. So here and here will be also 30. Right? Okay, so that means I can try to use the resolution method to find, okay, so the force which is adding downward is only W. And then the upward here will be, we have 2 cos 30 lah. So it'll be like this. T1 cos 30 will be here. For this line, okay, we find the vertical position will be here. Okay, so will be T1 30 cos lah. Okay, and then here also the same, also T1, and then will be also cos 30. So which is equal to mg, because the question just now mentioned this is in the equilibrium condition. Okay, so that means the force adding upward will be same as the downward here. So we get this equation lah. Okay. Okay, so T1 cos 30, we plus together, we get 2 T1 cos 30 equal to mg. And then you rearrange the formula, okay, will be like this lah. Mg over 2 cos 30 degree. So substitute m equal to 4, which is given by question. This is the mass of the mirror. And then the g is always 9.81 lah. Okay, this is a standard one. And then cos 30, you get 0.866. Then you get final answer will be 22.66 Newton lah. So your answer must be show at least 2 decimal places with the correct unit lah. Okay, so here you get 2 marks. First mark for the substitution, second mark for the answer lah. Okay, and then second, we need to get the value for T2. So T2 will be here. So we're using the same method lah, resolution method. Okay, so we look at the component vertical only lah. Okay, so again, there is a weight adding downward. Okay, and here the string will be moved to here lah, because we consider the point is here lah. Okay, and then we get the angle here will be 45 lah, because here is 90. Okay, okay, here is T2. Okay, and here is 45, and vertical opposite angle, we get these 2 angles will be 45. Okay, so the T2 here, we use the resolution method with the component of vertical will be here. So here will become T2 cos 45. And here also the same. You will get T2 cos 45 also lah, which will be equal to mg. Okay. Okay, so we're using the same method. We rearrange, we get T2 equal to mg over 2 cos 45. We substitute all the value, okay, which is given by the question. So we get the answer here, the T2 will be 27.75 Newton. Okay, I think this is quite straightforward also lah, huh? Okay. Okay, so based on your answer in 1B, which is the most suitable method to hang up the mirror? Give your reason. Okay, so here, just now we have get the tension 1 and tension 2 for the two mirror in diagram 1.1 and 1.2. Okay, and then we get the value for the tension 1, which is smaller than tension 2. Okay, so that means the tension 1 actually is more suitable. Okay, so tension 1 will be more suitable. Okay, so here will be T1, just how we get already, 22.66 Newton. And then the T2 will be this lah. Okay, this one actually is a figure of diagram 1.1 and 1.2. Okay, so we can just observe the value for T1. Okay, so we know that the T1, which is with lower value of tension, okay, will be not easily to broken. Okay, so here 2 marks. Firstly, you have to mention which method you will choose. So we will choose method in diagram 1.1. Okay, reason, because the tension of the string is smaller. Okay, smaller than T2 lah. Okay, the string will be not easily to broken. Okay, then for D, if the string in the diagram 1.1 is cut, the mirror will fall down in 0.4 seconds. So calculate the final velocity of the mirror before it touches the surface of the floor. Okay, so that means this mirror we cut, so it will be falling down to the ground lah, okay, to the ground. So the time given, dropping time will be t equal to 0.4 seconds. Okay, and then the initial velocity is also, we can actually get u equal to 0 because initially the mirror is in the stationary condition. Okay, and then the question asks us to find what is the value for V lah. Okay. Okay, so as mentioned, question given us already 0.4 seconds for the time reaction. G will be negative 9.81. This is acceleration for Earth lah. Okay, so 9.81. Okay, U is equal to 0 because the mirror is stationary, which is hanging on the wall. Okay, so here why we using negative for our G? Okay, because the mirror is moving down. Okay, so when the object is moving down, so we will assume that this is a negative reaction. Okay. Okay, so we're using the equation of the motion which you actually learned in your Form 4 Force and Motion 1 already. Okay, so we substitute all the value. Okay, we get V equal to negative 3.92. So the negative showing that the velocity is heading downward. Okay, so the V value will be 3.92 meter per second square with the direction of downward. Okay, so we'll get 2 marks. First mark for the substitution, second mark for the answer with correct unit and direction. Okay, okay, so we have finished our question number 1, which is regarding the subtopic 1.2 and 1.3. Okay, so now we go to our second question, which is discussion regarding the subtopic 1.4 here. Okay, so this is a quite long question. Okay, let us read together. So diagram 2.1 shows 2 identical steel balls placed onto string M and N. Okay, so M will be here lah. Okay, and then N will be here. Okay, so both strings are elastic, actually elastic, and fixed to horizontal surface. So you can see it's horizontal. Okay, so the springs are pushed down. So you can see here we have a hand for A and B also. Okay, so they will be adding a force to compress the spring M and N here. Okay, so the compression causes both of the length of the spring will be the same. You can look at the figure 2.1 here. So the length after compression, so both will have the same length. Okay, so diagram 2.2 shows the maximum height react by the ball when the hands are released. So when released, you can see at diagram 2.2, okay, so the steel ball will be moved higher for spring end. Okay, you can observe at the diagram 2.2 here. Okay, so here assume both of the spring have the same, using the same material, same coin diameter, and the same original length. So both will have the same length, same coin diameter, same material. So from this figure, the diagram 2.1, you can see the thickness of the wire is actually thinner compared to spring end here. So this is what we can observe before we do the question, right? Okay, so the first question, what is the meanings of the elasticity? Okay, so this one you have to memorize. Okay, so elasticity is a property of metal that enable an object to return to its original shape and size when forces that adding on it are removed. Okay, so you can see here, this is a figure. Okay, so when we putting the weight, so the spring will be extended. Okay, so the elasticity means that if I say we remove the weight, okay, from the spring, so the spring will return to its original shape and size. So that means the length will be returned to the original one. Okay, so here you can look at the graph. So before the elastic limit, so this is a straight line. So showing that the elasticity of the spring is still obey the Hooke's law. Okay, so after the elastic limit, so the spring is no more in the good condition. So we can say the spring is not have the proper elasticity already. Okay, so that means the elasticity of the spring referring to the point which is before the elastic limit. Okay. Okay, for the B, this is a conception question. Okay, so you can just observe the diagram and get the correct answer. Okay, so using diagram 2.1a and diagram 2.2, so compare the thickness of the spring wire. Okay, so just now I tell you already. Okay, so we just need to observe the spring M and N. Okay, so then you can see the thickness of the wire. Okay, so here you can just see very obviously. Okay, so the spring N is thicker than M. Okay, you can just write like this spring N greater than spring M. Okay, so the thickness so it's quite easy actually. Okay, and then second, the maximum height reached by the ball. Okay, so you can just observe the diagram 2.2. So you can see the maximum height reached by the ball for spring N. Okay, or diagram 2.2b. Okay, you have to mention diagram 2.2b is higher than A Okay, so you can just observe the ball. So you get diagram 2.2b is higher than diagram 2.2a. Okay, I think this is a quite straightforward question. You can just observe the figure. Okay. Okay, so then relate the thickness of the spring wire with the maximum height of the ball. Okay, so here you can choose to see B, 2.1b, 2.2b. So here you can see, okay, so when the thickness of the spring higher or thicker, okay, so the maximum height will be higher, right, for the steel ball to reach. Okay, so the maximum height of the ball increases as the thickness of the spring wire increases. Okay, or you can write another way also lah. The maximum height of the ball decreases. Okay, decreases as the thickness of the wire decreases also. Okay. Okay, so number 3, relate the thickness of the spring wire and the elastic potential energy of the spring. Okay, so you have to relate thickness of the spring and the elastic potential energy. Okay, so to understand this, okay, so you have to understand the relationship between the spring constant to the thickness of the spring wire. Okay, so spring constant indicate the stiffness of the spring. Okay, so for the thicker spring, that means that they will be more stronger, okay, more stiffer. So that means the spring constant value will be higher lah. Okay, so the thickness of the spring is directly proportional to the spring constant. Okay, so from this equation, this is the elastic potential energy equation. Okay, so here is relate the spring constant, okay, with the value of the elastic potential energy. Okay, so the K represent the spring constant, the X will be the extension. So as per mentioned just now, the extension for the spring M and N will be the same. Okay, because initially they have the same length, and after compress, both of the string also showing the same length also. So that means the extension here will be the same. So the difference here will be the thickness of the spring wire. So as the value K increases, so from here you can see the elastic potential also increases lah. Okay, so you can observe the spring end, so you can see it is thicker. So that means you will have a higher K, which is the spring constant, and also the higher elastic potential energy. So that means here there will be K increases for the thickness of the spring wire and cause the elastic potential energy increases. So here the relationship will be directly proportional. Okay, so you can write as the elastic potential energy of the spring increases as the thickness of the spring wire increases. Okay. Okay, so look at the C, question number C. Okay, so here the force used to compress the spring in diagram 2.1a and diagram 2.1b are F1 and F2 respectively. So compare the value of F1 and F2. Okay, so this is a figure. Okay, diagram 2.1. Okay, so both applying the force, okay, with different value here. Okay, although both compression causes the length, final length will be the same. Okay, so is it both F1 and F2 will be the same here? The question asking us lah. Okay, so here for the spring end, which is thicker, will be stiffer lah, which is stronger. So as per mentioned just now, okay, with the formula, okay, with this formula, we know that, okay, with the value K increase due to the thickness of the wire is higher for the spring end. Okay, so the potential elastic will be, energy will be increased. Okay, so how about F here? Okay, so here the extension is the same. So that means the X will be the same. So as K increases, so the E, value E will be increases. Okay, so we have another formula relate to force. So that means here the F will be increased also lah. So that means here the F2 is greater than F1. Okay, because the more force is needed to overcome the strength of the spring end here. Okay, so here the F2 will be greater than F1. So the reason, very straightforward, is due to the spring end is thicker, okay, compared to spring end, which is thinner here. Okay, so the spring shown in diagram 9.1b, actually 2, sorry, it's 2. 2.1, okay, 2.1 here. 2.1 B is made of thicker wire than the spring shown in diagram 2.1A lah. Okay? Okay, here, okay, so here I already show the answer already. Never mind, we just discuss together lah, how we get the value 0.15 joule here. Okay, so let us read the question first lah, okay? So spring M is fixed vertically as shown in diagram 2.3. So here is the diagram 2.3. So when 600 gram block placed on the top of the spring, so its length reduced from the 23 cm to 18 cm. Okay, so find the elastic potential energy stored in the spring. So we assume that the elastic limit is not existed. So that means it's before the elastic limit point lah. Oh, okay, so here initially without the wooden block, so the length for the spring end will be 23 cm. So after we putting the wooden block, which is 600 grams, so the spring will be compressed and getting shorter lah. Oh. Okay, so here the first we need to find out the compression X, so that means the length will be reduced. How many here lah? So be 23 minus 18, so we get 5 cm. Okay, so we need to change to SI unit in our calculation. Okay, then second, we need to know the force compress we apply, okay, or adding on the spring here. So here we're using F equal to mg lah. Okay, because here there will be weight adding downward lah, causes the spring to compress here. Okay, so question given us the mass for the wooden block is 600 gram. So we change to SI unit, which is kg, by divide 1000. Okay, so that means we get 0.6 lah. Okay, and then the second, the G is standard, which is 9.81 here. Okay, so we get 5.886 Newton here. Okay, and then second, we're using the formula which I already showed you just now. Okay, so the elastic potential energy stored will be equal to 1/2 Fx lah. Okay, so we get the F here already with the value of 5.886. And then the S will be the compression length. So we get 0.05 meter. So after that, you just press calculator. Then you get the elastic potential energy. Here will be 0.15 joule. Okay. So the 1 mark will be for substitution lah. Okay. So we will get this one first mark. Second will be the value for the elastic potential energy with minimum 2 decimal places and correct unit here. Okay. Okay, so the next will be question number 3, okay, which is regarding the subtopic of chapter 2, 2.1 and 2.3, gas pressure and the liquid pressure here. Okay, so let us read the question together. Okay, so students, you may also join me for the discussion and show your answer in the chat room. Okay. Okay, so diagram 4.1 shows an instrument which is used to measure the pressure of trapped gas. Okay, so the trapped gas will be here. Okay. Okay, so that means here we have the force of the gas adding at this point. Okay, and then this opening will be adding by atmospheric pressure. Okay, because this opening is open to air, right? So we have the atmospheric pressure acting at this point here. Okay. Okay. So name the instrument. Okay. So this one also quite straightforward lah. Okay. If you memorize, you get to answer lah. So here will be manometer lah. Okay. Okay. So then the next will be state one reason why mercury is used in the instrument. Okay. So here this is the mercury. This liquid will be the mercury. Why we using mercury? So here mercury has higher density. Okay, so as we know that the atmospheric pressure, if you're using mercury, so the value is about here given about 75 cm mercury. So if I say we're using the water, so the value for atmospheric pressure become 10 meter water lah. So the unit. So that means 10 meter is a very, very big and very tall instrument already. So we will be facing the difficulties to carry, to handle. Okay. So we will choose to using the higher density liquid. Okay, which is more able to carry. Okay, to conducting any measurement for the pressure. Okay, so the mercury is used due to the higher density lah. Okay, then the B, based on the diagram 4.1, calculate the pressure of the trapped gas. Okay, so the trapped gas is here as mentioned just now. Okay, so here will be adding by gas, and this opening will be adding by the atmospheric pressure. Okay, so for this, we have actually three different cases here. Okay, you can observe the level of the liquid here. So when you see the level for the left and right side, there is the same. Okay, so that means the atmospheric pressure and the gas pressure will be the same. So we get P gas equal to atmospheric pressure. Okay, and then the second case will be, you can see there is a different level between opening, which is to atmospheric pressure, and here will be the gas pressure. Okay, so here you can see the P gas here is greater than atmospheric pressure, so that the liquid of the mercury move to the another side. Okay, so P gas will be equal to atmospheric pressure plus H. Okay, and then the another case will be, you can see here also showing that there is the, okay, here the P gas is greater than atmospheric pressure. Just like I mentioned already, so we plus H. So the third cases, you can see here the gas pressure will be less than the atmospheric pressure. Okay, so that's why the liquid will be higher at the position which is at the pressure gas. So we're using minus H. Okay, so in our question here, you can see the level of the mercury is higher at the P gas. So that means the P gas will be smaller than atmospheric pressure. So we're using minus H. Okay, will be smaller than atmospheric pressure. Okay, so we're using this third cases. Okay, so P gas will be atmospheric pressure minus H. So atmospheric pressure given by question, this question is 75. Okay, we need to follow the value given by question. Okay, although normally it will be 76, but here we have to follow the value given by question, 75. So the H will be 12 minus 8. So will be here. So we get 71 cm mercury. Okay, so this is the first mark for the substitution, second mark for the answer with correct unit. Okay, then the C. Okay, so this question is the discussion regarding the subtopic 2.3, liquid, 2.1, liquid pressure. Okay, so diagram 4.2 shows an instrument is filled with water and liquid M. So the water will be here. Okay, so the dark color liquid here is liquid M. So the density of water is 1000 kg per meter cube. Calculate the density of the liquid M. Okay, so we need to find the density of M, liquid M here. And then G is given, standard 9.81 here. Okay, so here, firstly, you have to see the level here, the point X here, and the point Y here. They will have the same level. So that means the pressure at this point, Px, and the pressure at this point, Py, both will be the same. Okay, so here, the both side opening adding by atmospheric pressure. So here is actually adding also by atmospheric pressure. Here also the same. Okay, so we cancel out each other lah. So that means we can ignore the effect of the atmospheric pressure, since there is both opening to atmospheres. Okay, so we cancel out. So the liquid pressure here, we using the formula rho GH lah. Okay, and the H for this part, okay, adding at the point X will be H1. And then at this part, which is at the point Y, so the H will be 22 lah. Okay, so as per mentioned, at this point, this level, Px will be equal to Py lah. Both have the same pressure lah, liquid pressure. Okay, and we ignore the effect of the atmospheric pressure, we get this one, rho GH. So for this rho will be the density for water. G will be the gravity acceleration, okay, 9.81. Okay, the H1 will be here. And then for this part, pressure Y here, the rho M will be the density of liquid M, which we actually need to find out. Okay, and then the G will be the same. So that means later on we can cancel out. The H2 will be this, 22. Okay, we cancel out G, we substitute the value. So you get the answer for density of liquid M will be 727.27 kg per meter cube here. Okay, so the first mark will be the substitution here. And then the second will be the answer with 2 decimal places and correct answer, correct unit. Okay, so then the next will be explain how gas molecule in a closed container extend a pressure on the wall of container. So 2 marks here will be the explanation. Okay, so basically this is a closed container, okay, which is inside there is a lot of gas molecule which is moving randomly lah. Okay, so they will be collide to the wall of container. Okay, so the gas particle move randomly and collide to the wall container here. Okay, so if I say we using this area, so the force applied by the gas particle, okay, which collide to this surface, divide by this area. So we will get the gas pressure adding at this area, this surface lah. Okay, so with this formula, we know that the gas pressure is the force per unit area exerted by the gas particle as they collide with the wall of the container. So here, the first mark we have to discuss, gas particle collide to the wall of the container. Okay. Second, you have to mention the force. Okay, so here is impulsive force per unit area adding on the wall produce pressure. Okay, so if I say you just mention force per unit area, should be also correct lah. Okay. Okay, so this is a 2 reference answer for this question. Okay, then we go to question number 4. Okay, so this is a question regarding the subtitle 2.4 Pascal Principle. Okay, so diagram 8.1 shows an automobile hydraulic jack which is used to lift a vehicle in a workshop. So the system used Pascal Principle to produce a greater force to lift vehicles. Okay, so state the Pascal Principle. So this one you also memorize lah. Okay, so Pascal Principle using this, you'll be like this, right? Okay, so the formula here, the main point here is the pressure 1 and the pressure 2 is the same. Okay, so the Pascal's principle states that the liquid pressure in liquid can transmitted equally throughout the liquid. So that's why the P1 and P2 is the same. Okay, so this is the keyword you have to give in your definition. Okay, so number 2, if the pressure exerted on the small piston is 500 Pascal, what is the pressure acting on the big piston? Okay, so here, the small piston, here, the pressure acting is 500 Pascal. So as per mentioned just now, the Pascal principle states that the pressure transmitted will be equal. Okay, so here will be equal. So that means what is the value of the pressure? P2 here at the big piston. So that means actually will be the same lah. Okay, so pressure acting on the big piston here P2 lah will be same as the pressure acting on the small piston here P1. So the answer will be 500 Pascal. So 1 mark. Okay. Okay, then the next. Okay, so this question is question format for question number 8 lah, decision making. Okay. Okay, so table 8 shows the characteristic of the 3 hydraulic jack system. So here we have PQR. Okay, so the characteristic to study here first will be the cross-sectional area of small piston. Okay, second will be boiling point of the hydraulic liquid. Okay, here should be have liquid lah. Okay, and then material of the transmission pipe. So you have to choose which is the best lah, okay, for this hydraulic jack system here. Okay, so based on the table 8, give the suitable characteristic for hydraulic jack system to be used to lift heavy load efficiently. Give reason for the suitability of the characteristic. Okay, so here the first question asks you to choose, okay, you have to choose the bigger or smaller cross-sectional area at the small piston. Okay, so here you look at this figure. Okay, so you have to choose this piston, whether you want to choose the big or small area here. Okay, so according to principle, Pascal principle, okay, P1 equal to P2. So P equal to F over A lah. So we get this relationship. Okay, so from here, okay, so we can see the relationship between the output force F2, okay, is inversely proportional to area for small piston here. So that means if you want to have the greater output force, so we need to choose smaller area for the small piston here, so that we get a greater force, output force here. So that means we need to choose smaller. Okay, we need to choose the small, as mentioned, as the A1, small piston area reduced, so the output force will be increased. So we choose small. Okay, reason we want to produce a greater output force. Okay. Okay, then the second. So the boiling point of the hydraulic liquid. Okay, so we need to choose high here we have high and low. So we need to choose high, okay? So that it does not evaporate easily. Okay, this is the reason. Okay, and then the third one will be the material of the transmission pipe. So be this. Okay, here we have three types of the material. Okay, so we need to choose which one is stronger. So PVC is weak. These two will be weak. Aluminum also weak. So the best will be the steel. Okay, so because it is stronger. Okay, it's a very straightforward question here. Okay, so determine the most suitable hydraulic jack system that can be used to lift heavy load efficiently. So the first, we choose a small cross-sectional area of small piston. Second, we choose high boiling point or hydraulic liquid. Then the material we choose, steel. So that means the best will be Q. So answer here, Q. Okay, so I think we can have the break first. Okay, Pongko?
Okay. So kita nak berehat sekitar Cikgu nak berikan dahulu kod yang kedua iaitu 33. Bukan 33 lah, kami kata 33. Okay? Jangan ke mana-mana, nanti kembali selepas ni. Okey, baiklah. Kami kembali semula. Okey, jom kita teruskan bersama dengan Mr. P. Silakan, Cikgu.
Okay, so baru saya baca room check. Okay, so terima kasih cikgu, syukur dengan teacher Selinda join bersama saya. Okay, so we have already settled our section A. So we left section B and C okay, each one question here. Okay, so for question number 5, actually it's a question for section B. Okay, and here we will discuss the question regarding the subtopic of 1.2 and 1.3 here. Okay, so diagram 3.1 and 3.2 show an object of mass 30 kg. So here is the object with a mass of 30 kg sliding down into identical surface plane. So that means the plane surface will be the same. So they will have the same friction here. So diagram 2.1 shows the object sliding down the plane. Okay, so this one will be moving down. Okay, and then for the diagram 3.1, the inclined angle will be 45 degrees. And then for diagram 3.2, okay, so the object is stationary. Okay, and the inclined angle here will be 15 degrees. So the frictional force acting on the object, both will be 100 Newton. So that means here in the figure, here and here, this is a friction. Okay, so for case 3.1, the object moving down, so that means the Wx, which is the components of weight parallel to slope, is greater than frictional force. And 3.2, here stationary, showing that the Wx will be smaller or equal to frictional force. Okay. Okay, so this one I mentioned already. So the object at diagram 3.1 sliding down. Okay. And then the 3.2 is stationary. Okay, so that means the velocity is 0 here. Okay, so what is the means by the friction? Okay, frictional force. Okay, so here, force that act against the motion of two contact surface. Okay, so here you can see 3.1, so the object moving down, so the frictional force acting at the opposite direction of motion here. So be here. Okay, so also the same. Okay, so the object is stopped by the frictional force. Okay, actually the object is trying to moving down. Okay, but the force is smaller, which is Wx is smaller than frictional force. Okay, so the frictional force is always acting against the motion, okay, between the two contact surface here. Okay, then we go to question B. Okay, so B1. Okay, so based on the diagram 3.1, so we just see diagram 3.1, then we ignore diagram 3.2 here. So the components of the weight parallel to inclined plane Wx. Okay, so here you need to calculate what is the Wx here. Okay, so we'll be here. So from here is a triangle. So here, the 90, 45 here will be 45 right? So this is this part will be here So this will be a right angle Okay, so you minus these two angle, you get 45. Okay, so that means here will be W cos 45. Okay, so why here is cos? Okay, so we're using mathematics trigonometry So W here adding downward will be here. Okay, then Wx will be here. So the angle, this angle, W will be adjacent, and then Wx will be hypotenuse Okay, so adjacent over hypotenuse will be cos So that's why we get Wx equal to W cos 45. Okay, so that means we're using this formula Okay, so and here W equal to mg. Okay, so m given by the question just now, the object have 30 kg. This is given by the question, so it's m So we just substitute m with 30, g with 9.81, cos 45, then you get 208.10 Newton. Okay, 2 marks. So first mark for substitution, second mark for answer Okay. Okay, then the question asks you to calculate the resultant force acting on the object. So where is the same? We just observe the diagram 3.1. So we need to find the resultant force. Okay, so here is the diagram 3.1 and the value here just now we already know. Okay. Okay, and we need to know where is the resultant force. So just now from the question tells us the object in diagram 3.1 is sliding down. So sliding down will be moved down. So here will be the resultant force you need to find out. Okay, so this is a position parallel to the slope. So that means this Wx and the frictional force will be affecting the resultant force here lah. Okay, so here this is a frictional force given by the question, which is 100. Okay, so when moving down, so that means the Wx is greater than frictional force. So answer, resultant force will be Wx minus frictional force. So you get 108.10 Newton. Okay, you get 1 mark for the answer lah. That means, okay. Okay, then the third, also based on the diagram 3.1, calculate acceleration of the buoy. So that means the object actually is the buoy lah, with the mass of 30 kg here. 2 marks here. Okay, so we need to find the acceleration. Okay, as per mentioned just now, so the resultant force, okay, is 108.10. Okay, just now we get from number 2. Okay, so the object or the buoy is sliding down with acceleration A. Okay, so here we need to apply Newton's second law. Okay, F equal to ma. So m is 30 lah, mass of the object given by question. Okay, we're using F equal to ma. So just now we mentioned already, the question given us the mass is 30 lah. Okay, we just substitute 30. And then from the answer number 2, we get the resultant force is 108.10 here. So we rearrange the formula here. We get the acceleration will be 3.60 here. Okay. So first mark for substitution, second mark for answer with 2 decimal places and correct unit. Okay, then see why the object slide down in inclined plane when the angle is 45. The angle of inclination is 45 and remain stationary when the angle of the inclination is 15. Okay, so here you can see the figure 3.1, so the angle here is 45. So the angle bigger causes the object or the buoy moving down, and 15 not. So you need to explain why. So 4 marks here. Okay, so here the question already mentioned lah. Okay, so the object slide down. Okay, here the resultant force is 108.10 Newton. Then the friction 100 given by the question here. Okay, for both surface lah. Okay, and here just now I mentioned to you already, it moving down because of the Wx is greater than frictional force lah. Okay, so and the acceleration will be just now we get the value. So that means the object is accelerate and moving down in diagram 2.1. And then the 3.2 is stationary. So here you can try to, just now I mentioned to you, okay, so the Wx will be smaller or equal to Fr. So that's why the object is not sliding down. Okay, so you can try to get the value lah. Okay, so from here will be 75 lah. I already teach you just now, right? This is a right angle. So 180 minus 15 minus 90, you get 75 lah. Okay, so you get Wx value will be 76.17 here. So which is less than the frictional force. So this is the reason why the object not moving down when the incline angle here is 15 only. Okay, because the smaller angle causes the Wx smaller, okay, and smaller than Fr, that means the object will be stopped lah. Okay. Okay, so the first 2 marks you can discuss the motion at diagram 3.1. Okay, so the object can slide downward at an inclination angle 45 because Wx greater than the frictional force. Okay, you can straight using WX because the question state the symbol, meanings of the symbol already. Okay, and then therefore the object accelerate downward. So we get the value accelerate, right? Okay, so this is 2 marks for this question. For diagram discussion for the diagram 3.1. Okay, for discussion of diagram 3.2. So here the object stays stationary at angle of inclination 15 degree because the WX, okay, we just now count already, right? So it's smaller than frictional force. So therefore the object have the 0 velocity. Okay. So here is a reference 4 marks for this question. Okay, and then here is decision making. Okay, 10-mark question for section B. Okay, so table 3 shows 4 line painter machine, PQRS, with different specification. Okay, you are required to determine the most suitable line painter machine for drawing the line efficiently. So that means we need to choose the best design here where can draw the line clearly lah. Okay, so here the question asks you to study the specification for 4 line painter machine based on the following aspect. Okay, so here we have the example, we have the sample. Okay, so this is the line painter machine lah. So you can see this is a white line, okay, painted by this machine. So that means we actually need to choose the design, okay, here, okay, which will get clear painted line. Okay, so for the first one, you have to choose the method of moving the inclined painter. Okay, so here we have two methods. So when you using the machine, okay, you need to push the force or using pulling force. So here we have the 2 methods. Okay, so what is the effect here? Okay, so you can see if we do the resolution, so for this push force, so there will be a vertical force moving downward. Okay, and here there is a weight for the machine. So that means the downward force will be increased. Okay, you can see here both direction will be downward. So the downward force will be increased. Okay, so that means more force applied on the surface of the field already here. Okay, and when we using the pulling force, okay, so here is greater downward force, just now I mentioned to you already. Okay, so there will be a upward vertical force here, and there is a weight also moving acting downward. So here the downward force will be reduced. Okay, it will be reduced, right? Okay, so that means the force applied on the surface will be lesser lah. Okay, so that means here, for sure that logical thinking, so the line painted with more forces applied on surface will be more clearly lah. So that means we will choose push force method here. Okay, and then second, we need to choose the mass of the line painter machine. So here we have 20 kg and 10 kg. So which we need to choose. So we need to choose the heavier one. Okay, in your answer, you cannot give the value. So you need to give the heavier or lighter. Okay, so here definitely we need to have the heavier line painter. Okay, again, you can see this formula. So they will produce a greater downward force also. And one more is the heavier. So it will lowering the center of gravity and make it more stable. Okay, besides of increasing the downward force. Okay, so we will choose, okay, here when W increase, so the downward force will be increased. So we choose the heavier one. Okay, and then the third, size of the pen container. So here you need to choose a big or small. So we need to choose big lah, because can contains more pen and we can use for more longer time, and pen for more longer line. Okay, we choose the big one. Okay, can last longer time, mark longer line. And then the fourth is discussion regarding the angle between the handle and the vertical line. So here we have 15 and we have 25. So we need to choose the bigger angle or smaller angle. Here, if we calculate the Fy, so here will be cos, right? Just now I mentioned to you already in question number 1, right? 1 or 2. So here we'll get the value F cos 15. And here, the model Q will get F cos 25. So if I say they have the same F lah, okay, so with the value of cos, you can see the cos 50 will get 0.964 F. And then for this, you'll get 0.91 F only. So again, so the angle which is smaller will given you the bigger value of the downward component, okay, which is adding downward lah. So that means the value of the downward force will be greater when the angle is smaller here. So we'll choose smaller lah, okay, because the Fy will be bigger when the angle is smaller. Okay, so we have clear that, we'll choose P lah. Okay, so your answer here must be advised in table lah. Okay, so the first method we choose push method. Okay, reason, you'll get greater downward force. Because this value downward, okay, so you'll get greater downward force. Then second, mass expansion, we need to have the greater mass. Okay, mass, larger mass, okay, also the same lah, we need to produce a greater downward force. Or just now I mentioned to you, more stable, okay. Then the third, pen container size must be bigger lah. Okay, so that can contain more pen, so can pen longer line and last longer. Then the fourth, the angle, you need to choose 15 or 25. So as mentioned, the smaller the value of the angle, so the Fy value will be greater. So the downward force will be increased lah. So we need to choose smaller angle between handle and the vertical line. Okay, so again, same, produce greater downward force. So you have to mention 3 times. If let's say you mention only 1 time, so you get 1 mark only. So you have to mention 3 times. Although these 3 answer is the same. Okay. Okay, so we'll choose model P. So you copy lah, or so heavier push will be this push at the angle between the handle with smaller angle. Okay, and using the large pen container. So you'll get full 10 marks for this question. Okay, so the last question here will be section C. Okay, so the subtopic involved in this question will be 2.6 and 2.5 here. The knowledge principle and edge matters lah. Okay, so the question will be like this now. Diagram 9.1 and 9.2 shows 2 toy put are separated at 2 different distance at each other due to different in pressure. So you can see here for the diagram 9.1, so the both toy boot will be closer to each other, and then 9.2 will be far apart lah. Okay, so this is due to the water speed, okay, flow out from the hose here is different lah. So from here you can see the speed of the water flow from the figure 9.1 is faster compared to 9.2 lah. Okay, so what is the meaning of the pressure? So just now we mentioned already lah. Pressure, the formula will be F over A lah. So will be like this lah. Pressure is the force adding normally per unit area. Okay, force per area lah. Okay, so B1, using diagram 9.1 and 9.2, compare the speed of the water spurting out from the rubber hose and the distance of separation between the toy boots. So first, speed. As mentioned, you can see the hand is close the mouth of the hose lah. So making the flow of the water become faster. Okay, and here will be moving slower lah. Okay, flowing slower. Okay. Okay, so first, the speed of the water spurting out from the rubber hose. So diagram 9.1 greater than 9.2. So distance, here very clear that 9.2 will be further apart compared to 9.1. Okay, so distance of the separation, 9.1 smaller than 9.2. Okay, then next question, state the relationship between the speed of the water spurting out and the distance. Okay, so you can see here when the speed increase, the distance decrease. Okay. Okay, so this is the relationship you have to write. So you have to observe the diagram. Okay, so the higher the speed of the water spurting out, okay, you can see in diagram 9.1. So the distance between the toy boots will be smaller. Then the second, you have to set the relationship between the speed of water and pressure. Okay, so this one will be related to the Bernoulli principle. Okay, so the Bernoulli principle states that when the velocity of fluid increases, will be like diagram 9.1. So the pressure of the fluid decreases. Okay, and vice versa. Okay, so you can see in the diagram 9.2, so the speed of water flow is lower. Okay, so that means this region will be have the higher pressure. Okay, so the boot will be pushed, okay, to the lower pressure region here. Okay, so the answer, the higher the speed of water spurting out, the lower the pressure of water. Then the next principle, as per mentioned just now, it will be Bernoulli principle. Okay. Okay, then C 9.3 show the cross section of the Bunsen burner. Okay, so here using the physics principle explain how a complete combustion can be produced by Bunsen burner 4 marks. So you have to give at least 4 points here. Okay, so again here you can observe the nozzle, which is narrow. So the narrow nozzle will cause the gas moving in high speed. So when, according to Bernoulli principle, when the fluid flowing at high speed, the region will have the low pressure. Okay, so you have to discuss this. So the outside atmospheric pressure will be higher compared to the pressure inside the Bunsen burner. So it will be push the air into the Bunsen burner, and the complete combustion will be able to occur with the excess of the oxygen. Okay. Okay, so the first mark, the fast-moving gas flow out through a narrow nozzle. So this will be first mark. Second, the area of nozzle has low pressure. Okay, so the atmospheric pressure outside is larger. So the atmospheric pressure push air into the Bunsen burner through the air hole. Okay, so the air mixes with the gas and complete combustion will occur. So here will be 4 marks. Okay, then the last will be the modification. Okay, 10 marks question here. So this will be related to subtopic 2.5 edge matters. Okay, so diagram 9.4 shows the hydrometer, which is used to measure the density of liquid. Okay, you are required to modify the design in diagram 9.4 so that the hydrometer is more sensitive and can measure wider range of the liquid density. Okay, so you have to state and explain the modification for the following aspect. The first will be the length of the stem here, material of the hydrometer, diameter of the stem, size of the bulb, and the numbers of the lead shoot here. Okay, so the stem must be longer lah. Okay, so if longer, so you can get smaller minimum division. So that means it will be more sensitive lah. Sensitivity increases lah. Then the second, the material we choose glass lah, because glass will be transparent and will be easy to read the density. Then the diameter will be here. Okay, we have to choose smaller lah. Okay, smaller diameter so that the density will be also increase lah. Then the fourth, regarding the size of the bulb, here must be bigger. So bigger can displace more water. Okay, so the buoyant force will be greater and make it more stable. Okay, then the last will be the chute must be more also lah. Okay, so will become heavier and more stable. So again, your answer must be advisable in table lah. Okay, so the first stem must be longer. Reason, the minimum scale division can be made smaller. Second, the material we choose, glass. Okay, transparent, easy to read the density. Then the third one, diameter here must be smaller. Okay, so increase the sensitivity lah. Actually, same reason with the first one. Then the fourth, the size of the bulb must be bigger so that can displace more water, so can create more buoyant force and make it more stable lah. Then the last numbers of the lead chute must be more, okay, so can lower down the center of gravity and make it also more stable. Okay, so that's all for my sharing today. Okay, so thank you.
Okey, terima kasih kepada Mr. P yang beri banyak maklumat soalan-soalan yang keluar dalam paper tu. So kena belajar ini ialah tips yang boleh tolongkan anda semasa nak applykan peperiksaan. Yang ni soalan-soalannya lah ada tahun lepas, ada percubaan punya trial exam. So belajar memang ini banyak membantukan anda. Okey, so kami tanya dan terima kasih ucapkan kepada semua yang setia untuk mengikutkan kelas petang ni. Okey, sebelum kita nak tamatkan sesi siaran langsung hari ini, mohonkan semua penonton tutupkan luangan chat, klik butang subscribe dan juga aktifkan ikon watching supaya kamu tidak akan terlepas dengan sesi kelas Mr. P yang seterusnya. Okay, sila klik like dan juga share kelas kita hari ini kepada rakan-rakan di media sosial anda. Jangan lupa ikut kelas-kelas fizik seterusnya iaitu pada setiap hari Jumaat 9.30 malam untuk tingkatan 4 dan juga Ahad pukul 2 petang seperti hari ini untuk tingkatan 5. Okay, layani portal www.academyyoutuber.com untuk mendapatkan info yang terkini berkaitan kelas tuition percuma AYU dan kongsikanlah kepada rakan-rakan dan juga guru di seluruh Malaysia. Okay, so sampai masa ni kami link sijil, link rekod kredit pelajar dan juga username Mr. P telah diletakkan di ruangan chat lah. Sila ambil perhatian link tersebut hanya akan tamat setengah jam lah selepas kami lepaskan dia punya link lah. Okey, selepas live ni lah. Okey, pastikan anda login dengan menggunakan email yang tadi ada sebut, iaitu email e-didik, email MOE, email MyGuru dan juga email Jawi untuk membukakan link yang berkenaan. Okey, So last but not least, kami mesti menjemput balik cikgu-cikgu sebelum nak tamatkan kelas ni. Okay, saya jemputkan Mr. P, ada apa nak beritahu belajar sebelum dia exam.
Okay, so pertama lah kamu kena tahu format kan. So contoh tadi saya ada berikan contohnya soalan 5 dan 6. Biasa dia akan tanya soalan conception. So jenis soalan ini sebenarnya kamu perhatikan gambar. Okay, so kamu boleh jawab tanpa memorize apa-apa lah. So sekiranya kamu boleh tahu format, tahu cara menjawab, dia lebih senang mendapat markah yang tinggi lah. So tapi masih perlulah bersungguh-sungguh buat ulang kaji lah. Okay, supaya kamu dapat keputusan yang baik lah. So kita Cikgu Ayu sekarang sentiasa bersama anda, okay, membuat ulang kaji untuk menghadapi peperiksaan yang akan kamu hadapi nanti inilah. Okay, thank you.
Okay, terima kasih Mr. P. Okay, Cikgu Izia ada apa nak pesan belajar?
Okay, terima kasih Teacher Kok. Okay, Cikgu nak ucapkan tahniah lah kepada semua yang menonton kelas tuition percuma ni. Hampir kepada sejam setengah. Okay. Banyak tips daripada Mr. P untuk anda menjawab peperiksaan. Jadi cikgu nak ucapkan selamat menghadapi peperiksaan pertengahan tahun. Jawab ikut tips yang Mr. P ajar. Semoga anda semua mendapat kejayaan yang cemerlang. Okey, itu saja Teacher Kok.
Okey, terima kasih. Okey, belajar dah dengar, cikgu-cikgu dah pesan, belajar kena jawab soalan dengan berhati-hati dan juga sila underline keyword perkataan yang penting dalam soalan. Okey, itu ialah apa yang cikgu boleh share dengan anda lah. Okey, akhirnya kod kita yang terakhir untuk bagi belajar iaitu 68. 68. Okey. So, terima kasih kepada semua penyokong Akademi YouTuber. Okay, sekian daripada kami. Salam hormat dan jumpa lagi next week. Bye.
Berita baik untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata gancaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.